For the third subtopic, it is on heat conduction. So in this subtopic, you should be able to define what is heat conduction, solve any problems related to rate of heat transfer through a cross-sectional area, so maximum two insulated objects in series lah. Lastly, you have to be able to analyze the graphs of temperature against distance for heat conduction through insulated and non-insulated rods, again maximum two rods in series. So we always talk about heat and temperature, but realistically, we actually think they are both the same thing, because I would say when I was a student, I would say they are actually the same thing. But when you start to learn physics, there's actually a difference between these two terms, okay? So heat is actually a form of energy which is transferred from one object to another due to the differences in temperatures between any two objects, okay? Between objects. So the symbol is Q. Temperature pula, temperature is a relative measurement of hotness ataupun coldness of an object. So temperature is telling us how hot the object is. Heat, on the other hand, is an energy that is transferred from one object to another object. Okay, the SI unit for heat is joule, whereas for temperature it is Kelvin ataupun degree Celsius. Heat flows from a region of higher temperature to a lower temperature, and it can be transferred through conduction, convection ataupun radiation. Temperature pula is a scalar quantity that is the same for any two systems that has reached thermal equilibrium. So it will be, the temperature would increase when it is heated, decrease when it is cooled down. Okay, so that is on heat and temperature. Heat conduction. So heat conduction is a process where heat is transferred through a solid from a region. Oh, okay, sorry. So I read that wrongly. Okay, so heat conduction is a process where heat is transferred through a solid from a region of higher temperature to a region of lower temperature. So higher temperature going to a much lower temperature. So it does not go from low to high lah. Dia dari high dia pergi the low temperature. Okay, so it happens by direct contact of matter. For example, when we are heating up the rod here, there's a transmission of heat from this fire throughout this rod here. So what is happening is the atoms are energized and vibration will increase. So the vibration is spreading through the material. So the atoms start vibrating when it is heating up lah, when it is heated up. Okay, so basically that is graphically what is happening when you are heating up something. So the rate of heat transfer, it is Q over T. It is okay, so let's consider a properly insulated slab of material with cross-sectional area A and thickness dx. So this is the cross-sectional area, this is the thickness. So one face of the slab is at temperature T1. So this is T1 and the other temperature is T2, where T2 is less than the temperature of T1. So it is found experimentally that the rate of heat transfer is given by the relationship, by this equation here, okay? By the relation, that equation. Okay, so Q over T is the rate of heat transfer, A is the cross-sectional area, K is the thermal conductivity. So you remember, for this subtopic, K is the thermal conductivity, but for this subtopic just now, K is our force constant. Alright, so make sure you are calculating ikut subtopic lah. So the question, make sure kamu tidak get confused. Delta T over L, which is this one, is what we call as temperature gradient. Delta T is the difference in temperature between the cold and hot phases. Sorry. So the equation is T2 minus T1. L is the thickness of the material. Thickness of the material that is conducting heat. So basically it's just the distance between the hot and cold phases. So it's from the hot phase until the cold phase. So the negative sign here is actually telling us that the heat will be flowing in the direction of decreasing temperature. So it will go towards the decreasing temperature. So that's why they added the negative sign there. And then the rate of heat transfer is a scalar quantity. It has the SI unit either joule per second ataupun you can also write it as watt lah. Okay, that is on rate of heat transfer. Thermal conductivity, which is K, it is the characteristics of heat conducting ability of a material, which indicates how fast it can conduct heat. Okay, so berapa cepat dia boleh dapat rasa panas benda tu, begitu. So it is defined as a rate of heat flows perpendicularly through the unit cross-sectional area per unit temperature gradient along the direction of heat flow. So the definition is really quite long, but if you want to write it as this, there's no question on definition for your PSPM because that is C1, C2. So yours is C4, C5 if I'm not mistaken, C3, C4, sorry. So this is your equation of thermal conductivity lah. So it is a scalar quantity. It has the SI unit of watt per watt per meter per Kelvin. Okay, macam tu lah. Yang kalau degree Celsius, watt per meter per degree Celsius. So it is a proportionality constant that depends on the material. So it fully depends on the material. So anything that are good conductors would have a larger thermal conductivity, whereas good insulators have low thermal conductivity. So maksudnya dia tidak cepat panas lah maksudnya. Okay, let me just double check on the unit because I think I wrote something. Yeah, so the watt isn't supposed to be per watt for the Kelvin. It should just be watt per meter per Kelvin. Okay, all right, so here are some of the thermal conductivities for various substances. Styrofoam has the lowest thermal conductivity, so yeah, whereas silver, copper, the one that we always use in our daily cooking, is the one that has larger thermal conductivity because it is able to conduct heat more faster than other materials lah. Okay, so let's look at heat conduction through jointed rods. So let's consider these two different properly insulated rods, X and Y. So they are both insulated and have the same uniform cross-sectional area, but they have different lengths and thermal conductivities. Okay, so sekarang T1 ni is greater than T2. So heat is flowing from this slab to this slab here. Okay, so when the rods are in steady state, questions will always mention when they are in steady state, when the heat flow is steady, when they are in equilibrium. Okay, so what you can write is the rate of heat flow through material X should be equal to the rate of flow to material Y as well. So mathematically it is written this way. Okay, so make sure this part here you remember lah, sebab kalau di sini ni sudah yang ini actually KA ada negatif batu, tapi sebab nanti cancel je, so don't really care about that lah. But this is delta T over the thickness L. So this delta T untuk the first one, it will be the adjoint minus the first slab. But for this one, it's gonna be the cold end punya slab minus dengan the adjoint punya temperature. So make sure you remember this part here lah, sebab itu yang selalu students do mistakes, so they got the wrong answer lah. Okay, now let's look at the graphs of temperature against distance. So last time saya jaga exam physics, one questions come up is drawing the graph of either four of this. I don't remember which one, but soalan tu adalah minta. So kiranya macam, I guess you need to kind of remember ataupun memorize the graph for each four of this, right? Yeah, so let's look at the heat conduction through insulated rods. So since they are properly insulated, there will be no heat escapes from sides to the surrounding. So the rate of heat flow is constant, temperature gradient is also constant, and so the temperature varies linearly with distance along the rod. Okay, it goes down because this is the hotter end, this is the cold end. So decreasing of temperature is uniform for insulated rod. Untuk non-insulated rod pula, heat is escaping to the sides of this rod lah. So heat is lost to the surroundings. So the quantity of heat flowing from the hot end through a cross-sectional area per second gets lesser and lesser as it moves along the rod towards the cold end. Sebab dia semua tu pergi surrounding. So yang sampai di sini sikit saja. So apa yang terjadi is the rate of heat transfer will be smaller and smaller as it moves towards here. So the same is true for the temperature gradient. That's why it is going like a, what graph is this? Is it a lawn graph? Let me just check if I'm correct. Oh. Is it oh yalah. Bukan lawn graph ka to. Tapi dia terbalik. Is it? Ataupun graph. EX graph. What do we call that, Sudha? What graph is EX graph? Exponential graph. So this is an negative exponential graph. Negative exponential graph lah kali. I don't know actually, whatever. So basically the graph is like that lah. So the gradient decreases as we move towards the cold end here. Okay, now let's look at the insulated combination of rods in series. Yang tadi ni satu material. Sekarang ni dia ada dua rods. So bila ada steady state, the rate of heat flow going through these two materials will be the same. So that's why we put it that way. And then if you look at the thermal conductivity, the one that has a greater temperature gradient would have a much lower thermal conductivity, and vice versa lah. So that's why the temperature gradient that's why they are talking about this, because it depends on the temperature gradient. Alright, now let's look at the heat conduction to non-insulated combination of rods. So something is weird about this. I think it's not done, but it's okay. But for this one, heat is lost to the surroundings, so the temperature decreases non-uniformly with distance. Value of K is different, so the curve for two of these are different lah. They're not the same because they are two different materials. Alright, so that is on graphs. And then let's look at these two examples. So example number 3. So we have two properly insulated uniform rods D and E. They make thermal contact at one end here. So the cross-sectional area of both rods are the same. The rods are in a steady condition. So we have to determine the temperature gradient along rod D. So how do we do that? First, we extract a few informations from what we can see from the diagram. So we have the temperature for material D is 100 degrees Celsius. You can also write it as T1. It's really up to you. But I'll put the adjoint temperature as just T lah, supaya senang. And then T2 is for TE. Oh, okay. Now you can't because susah lagi ni. Put adjoint je lah. Sebab T2 is T degrees Celsius, sudah ditulis sana. Okay, and then the thickness, which is X ka pula. Oh, okay, sorry. XD is 0.2 meter. Thickness for material E is 0.4 meter. Okay, so is that it? Yeah, that's basically it. So we have to determine the temperature gradient along rod D. So temperature gradient is delta T over X. Okay, so that is for material D. So this is gonna be delta T untuk the first material will be the temperature of the adjoint minus the temperature of the material, and then this is the thickness. Okay, so dari situ kamu just substitute lah. 80 minus 100 divided by 0.2, you will get negative 100 degrees Celsius degree Celsius per meter. So that is the temperature gradient punya unit lah. Next, the temperature at the free end of the rod E. So since the question mentioned that they are in steady condition, we can state that the rate of heat transfer for both materials is the same. Okay, so if we substitute the cross-sectional is the same, so we can just put A there. We can write like this. If you want to remove the negative now, it's entirely up to you, but I'll always just keep it there because time substitute number tu, time simplification tu barulah kasi cancel gitulah. Okay, so we can cancel this, and then we have the value of that temperature gradient for D. So we are left with 100 here, negative 100, and then we have negative 2/3. Actually, the negative boleh cancel sudah sekarang. So, tak payah tulis pun boleh lah. I think so. Would it be something? I don't really think so. So, KE is 2/3 K. Okay, dia ada tulis ni ya. KD is equal to K. So, lupa pula. Di sini K. So, this is gonna be the outside minus the adjoint over XE. So, dari sini kamu akan dapat T equal to 20 degree Celsius. So, that is the temperature at the outside, at the free end of rod E lah. Okay. Lepas tu kita perlu sketch and label a graph to show the variation of temperature with distance along D and E. So let's just try and draw it. Sketch dia ba? Dia payah pun rough. It's just a rough sketch. So the highest temperature is 100, and then we have 80 degrees Celsius, and then we have 20 somewhere there probably. And we have 20 centimeter and then 40 centimeter. So this is your temperature, which is in degrees Celsius. This is your distance, which is in centimeter. So this is 20, this is 40, 100, 80, and 20. So it goes from 100 to 80 degrees Celsius for 20 centimeter. So lukis lah, kung nakalalain ka pa ka sukati. So it goes day. Wala ito roughly dyan. Okay, lepas tu suruh cari untuk dari 80 degrees Celsius dia pergi 20 degrees Celsius. So it goes from 20 centimeter pergi 40 centimeter. Terlebih pula. Sini je kali. Okay, so what I was trying to do just now is making sure it's actually in line with what we are drawing. Bukan what we are drawing, with the scale. Begitulah. Gitu. Alright. Let me just kasi betul yang ini. Okay, gitulah kamu punya graph. Kalau kamu rajin, kasi buatlah dia punya garisan putus-putus. But if you don't want to, I guess it's not really gonna cost you any marks. It's just looks much more nicer. Ini buat kalau kamu ada masa lebih lah, kan time exam tidak tahu jawab, tiba-tiba kamu buat ni je. Okay, so that is the graph lah. Did we label everything? Yeah, we did. So yeah, full mark. Example 4. So we have a copper plate that has a thickness of 1 centimeter. Thickness dia 1 centimeter. Copper 0.01 lah. It is sealed to a steel plate of thickness. Steel is S. 10 centimeter. So that is 0.1 meter. So the temperature of the exposed surface of copper is 30 degrees Celsius. I'll label that as T1. And then T2 is for the steel, which is 15 degrees Celsius. So we have to determine the temperature of the interface between the copper and the which is somewhere here. So we have to find T. Okay, so how do we do that? Let me just wait. Okay, so since there are no energy lost to the surroundings, it should have the rate of heat transfer should be equal for both roadsters because they are in steady state. So what we can do is Q over T is for copper equal to Q over T for steel. So KCAC, did they have the same cross-sectional area? They should have, yeah. They just don't have the same length. Sorry. So this is A, this is delta T over X, copper, KS delta T over X untuk steel. Okay, so it's the thermal conductivity is given there. A can be cancelled, and then we are left with KC delta T is T adjoint minus T1 over XC equal to KS T outside minus T adjoint minus over XS. Okay, so dapat yang ni, just substitute the value. T minus 30, 0.01, 50.2, 15 minus T over 0.1. So dapat T equal to 29.8 degree Celsius. Okay, so mostly most students would find problem when dealing with this equation here. Dorang punya number betul tapi they did something wrong mathematically. So basically the maths is wrong bila dia bisa pindah-pindah gitu. So make sure double check macam mana kamu solve after dapat this equation lah. So jangan buat any careless mistakes. Lepas tu question B, we have to calculate the amount of heat flowing from the copper plate to the steel plate in 1 minute. So given time is 1 minute. So that is 60 seconds lah. If the cross-sectional area is 50 centimeters square and no energy is lost to the surroundings. Okay, so in this case, we can just choose either one of the plates because they are in steady state. And oh sorry, kejap. Oh yalah, betul lah. So the rate amount of kejap. The rate of heat flow would be Q over T equal to negative KCAC delta T over XC. Okay, so KC is 385, A is 50 times 10 negative 4, delta T over X is 29.8 minus 30 over 1 centimeter, which is 0.01. So dapatlah the rate of heat transfer diminta in 1 minute. So Q, this is 60. So dapat should get 2310 joule, but let me just double check if it's correct. Okay, 385, 50, 29.8 minus 30 over 0.01, 60, yeah, 2310 joule. Okay, so that minta amount of heat flowing, not rate of heat transfer, but we are using this because dia bagi minta dalam 60 seconds. Okay, so that is basically the solution for example number 4, and that is the end of subtopic number 3.